Hello everybody. This is your practice problems video for central and inscribed angles. So you'll notice that everything for this section is all in one document. So for this this question here, or this set of questions, we're only going to go up through number 7, okay? Because most of the last page of practice problems deals with chords and secants and tangents. All right. So let's go ahead and jump into it here. And I realize on this video that everything is misnumbered, that yours, it'll probably be fixed on your version of the document, but it's not currently fixed on mine. So there it is. Let's go ahead and jump into this first one right here, which says, use the circle shown, it should say to the right, to determine the following. Okay, so I'm using this image here. Okay, so it looks like I have this central angle of 8x and this intercepted arc of 96 degrees. So the question is, what is the measure of the central angle? So when we say the measure of the central angle, that means I want to know how many degrees it is. Okay, and the rule for central angles is that the angle is equal to the arc. Okay, so since the arc is 96 degrees, then that means the angle has to also be 96 degrees. Okay, it's that simple. You don't have to make it any more complicated than that. Okay, and then part B here says write and solve an equation for x. So I know that the angle has to equal 96 degrees. And I also know that the angle is 8x. So my equation is 8x equals 96. And then I'm just going to divide by 8 on both sides. Okay, so when I do, I get that x is equal to 12, right? And that's it, okay? Now part C is talking about a slightly different idea, which says, what is the measure of the angle that bisects the minor arc? Okay, so the minor arc is the intercepted arc. It's this arc. Okay, the one that I have traced in blue here, the 96 degrees. Okay, so I want to know what's the angle that would cut that in half, right? So all I got to do here is okay, so what's 96 divided by 2? Okay, and 96 divided by 2 is 48 degrees. Okay, notice that for x, I didn't put a degree symbol because x is not really a degree measurement, it's just a variable. In this case, right? But here I'm looking for the measure of an angle, so I got to make sure I put a degree measurement in my answer, okay? All right, so let's take a look at number 2, which says to find the measure of angle x, or the measure of x in circle C shown to the right. So this circle here, again, this should all be fixed. All the language should be fixed on y'all's version of this. It's just not fixed currently on mine. So she set up this equation. She said 12x plus 6. Okay, so this part, 12x plus 6 plus 3x minus 6, so this part, equals 360. So the question is she correct? Did she set up her equation correctly? If yes, solve for x, and if not, explain. Well, I know that there's 360 degrees in an entire circle, but the 12x plus 6 and the 3x minus 6 only account for half the circle, right? This is only 180 degrees of the circle, because see how it goes from one end of the diameter to the other, right? So it's only a semicircle. So instead of 360 right here, this should be 180 if I wanted to solve this. Okay, so that's what I'm going to write, and then I'll solve it for you as well, but you didn't technically have to solve for x because it just said to explain why she's incorrect. So I would say no, her equation should be set equal to 180 because the two arcs given only make up half of the circle's circumference. Okay, i.e. 360 divided by 2, which is 180. Okay, so now this question did not ask you to solve for x, but I'm going to go ahead and do it just to give you all some practice. If you want to do it with me, you can. So the left side of the equation is going to stay the same, 12x plus 6 plus 3x minus 6, but the right side now is going to be equal to 180. Okay, so I'm going to combine my like terms. So I have 12x plus 3x, so that's 15x. And then I have plus 6 and minus 6, so those actually cancel each other out. So all I have is 15x equals 180. So I'm going to divide by 15 on both sides, divide by 15. So you end up with x is equal to 12. All right. So that would be the actual solution if you wanted to go through and solve that one. Okay. So those are your questions on central angles. Okay, and then the next couple are going to work with the inscribed angles and inscribed quadrilaterals. Okay, now I know once we get to this point, the numbering is off. Sorry about that. Okay, so let's take a look at this lovely diagram right here. Okay, so I have an inscribed quadrilateral here, this looks like an inscribed trapezoid, but I can't be sure because I'm missing some parallel lines. Like I don't know if these lines A, B, and DC are parallel. Don't know. So I'm just going to go with it's just an inscribed quadrilateral. I know that this angle DCB is 140, and that's it. And I also know that AB is a diameter. Okay. So I'm going to make a note of that for myself, that AB is a diameter. Okay, so the first question is, which angles in this inscribed quadrilateral, if any, are right angles? Okay, so here's the thing. A right angle, as you recall, is 90 degrees, okay? And all of these angles that you see, angle A, angle B, angle C, and angle D, and even these parts, right? So like see how angle D is split up into two different parts, right? Angle ADB and angle BDC, right? There's two different ones there. But they're all inscribed angles, okay? They're all inscribed angles, right? So these are all inscribed. Okay, so if I want my angle to be 90, right, then that means it has to intercept an arc that is 180 degrees. Okay, because if you recall, right, remember the rule is 2 times the angle has to equal the arc. Okay, so if my goal is to get right angles, 2 times 90, that has to equal the arc. So the arc has to equal 180. Okay, so I need to look for one of these inscribed angles that intercepts an arc that's 180 degrees, or half of the circle, right? So I'm just going to pick one at random to kind of test to show you what I mean. So let's say I wanted to see if angle A was a right angle. Now it doesn't look like a right angle, but it might be, so we have to check, right? So the actual angle A goes from here to here. So its arc, its intercepted arc goes from here to here in purple. And now obviously that does not make up 180 degrees, right? It's definitely less than 180 degrees because it doesn't go all the way around from point B to point A, right? That's the only way I can know for sure that I'm dealing with a semicircle, right? If you have a diameter in there, okay? So in looking at my image, my only semicircle is this one, right? Going from A to B. So the angle, or really the only one that's going to work for me, right? So let me do some erasing here. Okay, so the only angle that intercepts that arc is this one, right? So that angle right there has to be a 90-degree angle. Okay, so the answer to this question is angle ADB is a right angle. Now, I have to be careful here. I can't just say angle D, because remember there's two angles as a part of angle D. There's this one that's 90 degrees, and then this other one here, which very obviously is not. Okay, right? So that would be my final answer, angle ADB. Okay, so looking at the next one, it asks, what is the sum of DAB and DCB? Okay, so I need to figure out where those angles are. Remember, start with the first letter and then follow the way that the angle is written in order to figure out where that angle actually is. So DAB is this angle right here. Okay, and then DCB is this angle right here. Okay, so notice those are opposite angles in an inscribed quadrilateral. So their sum has to be 180 degrees. Okay, so the sum must be 180 degrees because these two angles are opposite angles in an inscribed quadrilateral. Okay, and that's really all you have to say because that's the rule. All right. Okay, then this last one here that goes with this idea, let me do some erasing here because now we've lost all of our numbers and everything that's going on inside of this figure here. Okay, so this last question is identify the angle that measures 40 degrees. Well, the only angle that we know is this one, 140. But remember from that last one, I know that these two angles across from each other have to add up to 180. And 140 plus 40 equals 180. Okay, so then that means angle DAB plus angle DCB has to equal 180. So I have angle DAB plus 140 equals 180. So that means that angle DAB equals 40 degrees. All right, so that's it for that question. So we've got one more, and this one is going to involve a little bit more algebra. Okay, it's this last one right here. Okay, so I have this figure, okay, and I know that the angle, the inscribed angle is 10x minus 5, and the arc, the intercepted arc, is 16x plus 22, okay? Now, I need to go back to my rule for inscribed angles. Okay, so the rule for inscribed angles is 2 times the angle equals the arc. Okay, so I'm going to plug the information from my image directly into this equation. Okay, so I have 2 times my angle, and my angle is 10x minus 5. Has to equal the arc, and the arc is 16x plus 22. Okay? All right. What you're going to see in a lot of angles in circles problems is things like this, where you have the rule, you have the geometry relationship, and you have to use the image to plug the expressions that they give you or the numbers that they give you into the right spot. And then the actual geometry part, right, the geometric relationship, you're done using it. After that, you just have to figure out, using your algebra skills, what your variables are. Okay, so that's exactly what I'm going to do with this one. So now here's the thing. I have two different ways that I could solve this. I could use my distributive property to distribute the 2 and multiply the 2 through. If you want to do it that way, you absolutely can. But what I'm going to do, there's another way you can solve this, okay, which is by dividing both sides of the equation by 2 to cancel that 2 out. The reason I'm going to do it that way is just so that my numbers stay a little bit smaller and it's a little easier for me to solve. But you would end up with the exact same answer if you used the distributive property. Okay, so it would be fine either way. All right, so what I'm left with, if you solve it my way, is doing, I have 10x minus 5, because I got rid of that 2, equals, and then I'm just dividing all of these values by 2. So 16 divided by 2 is 8, so I have 8x plus, okay, and then 22 divided by 2 is 11. All right, so let's go ahead and solve this. So what I'm going to do is I'm going to move the numbers first. So I'm going to do plus 5 plus 5. So I end up with 10x equals 8x plus 16. Then I'm going to do minus 8x because I've got all of my numbers together on the right side of the equal sign now. So I need to get all of my variables together on the left side of the equal sign. So you end up with 2x equals 16. And then I'm going to divide by 2 on both sides. Boom. So your final answer is x is equal to 8. Okay, that would be your final answer. And the reason I know it's my final answer is because if I go back up to the question, it wants to know what the value of x is. Now, what if they had said, how many degrees is the angle? Right? What you would have to do is take your x value and plug it back in to solve it. So if the question was, what's the angle measurement? Right? I would do 10 times 8 minus 5. So that's 80 minus 5, which is 75 degrees. Okay. This question obviously did not ask that, but I just wanted to show you as an example, right, that that's what you would do. If it asked you to find the angle measurement, if it asked you to find the arc measurement, you'd plug your x value back here into this expression, the 16x plus 22. All right, y'all, so that is it for this video, and I will see you in the next one where we're going to talk about intersecting chords and intersecting secants and intersecting tangents. All right, so I'll see you in the next one. Bye, everybody.